Dark out, it's raining, but I thought I would come and balance an equation. And since it's getting close to Halloween, maybe it'll be spooky. Um, Here we have a combustion reaction, also a rapid oxidation. And we see that because in this case it's an organic and we've got oxygen added to both products to make carbon dioxide and water. That's a really important thing to remember. And I've already showed you how to balance one of these things, but I thought it would be a good, easy way to start before we get into like the ionic reactions and precipitations and redox and all that. So when I look at this, I notice that I've got 5 carbon here and I've only got 1 here. So if you remember, what we should be looking at is the Sulu method, because Sulu is played by John Cho. That's not confusing. And what that tells us is to do the carbon, then the hydrogen, then clean up the oxygen. And so looking here, we realize we've got carbon, we've got hydrogen, and then we've got oxygen here, 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 and here, and that's why we do it last. So the first thing I notice is that I've got 5 carbon in the reactant side, but I've only got 1. So I'm going to write this a little smaller. Maybe I can make it neater. H10O2 liquid plus O2 gas yields 5CO2 gas plus H2O liquid. Okay, so this is my first move. So I put a 5 there. And so now I have 10 oxygen here, but I'm not worried about that because I'm doing the Sulu method. So I have 10 hydrogen, and so only have 2 hydrogen here. So I'm going to do another 5. So 5 and 5, these numbers won't always be the same, it just happens they are this time. And so now I have 2 and 2 is 4 oxygen. And this is one of the reasons I picked this, is make sure when you're doing your final balances and when you're doing your counting, you account for all the different places an element is. So that could really screw you up, especially in this case. What I find a lot of people doing is they balance and they forget this guy's there, or they don't take those 2 into account, and so it'll throw off your balance. So right now I've got 2 and 2 is 4, as we said, but over here I've got 5 times 2 is 10, plus another 5. Oh, bunk. Okay. So 10 and 5 is 15. Well, that's a whole other problem, isn't it? So essentially, I take the 15O2 and then let's go minus 2. So we'll just say minus O2. And so I need essentially 13, because 5 times 2 is 10 plus 5 is 15, and then I'm getting rid, so I don't need 13. That's not the right way to put that. I need 13 oxygens. That's the right way to talk about that. So I need 13 oxygens because I'm taking these 2 out because I'm not going to manipulate this anymore. Okay, so I'm taking these 2 out. So if I have 15 oxygens and then I take away 2, I have 13 oxygen atoms. So I need something here that multiplies times 2 to 13, which not that hard. But it'll have to be 6.5, okay? So you see here, now we've got a balanced equation because we have 5 carbons, 10 hydrogens. 5 times 2 is 10 hydrogens. Now I'm going to go backwards on the oxygen. 5 times 2 is 10 oxygen plus 5 is 15. Now here, 6.5 times 2 is 13 plus my extra 2 is 15. Now the only thing I don't like is having a 0.5 in a balanced equation. So what I'm going to do is I'm going to double everything there. So I just double everything. And my finished balanced equation is going to be 2C5H10 O2 liquid plus 13 O2 gas yields 10 CO2 gas plus 10 H2O liquid. Now, let's talk about a little bit of stoichiometry. So, I'm going to, if my kids had left, oh, here we go. Okay, so I'm just going to roll this dice, okay? It is a 10-sided dice. So I rolled an 8, okay? So I'm going to say that I start out with 8 moles of our reactant here, okay? 8 moles. And I'm going to ask how many moles of this will be made, okay? So all I have to do is once I balance the equation, I have to set up the ratio of how much of this relates to this. So I'm going to start out my problem, and we've done this a little bit before already. 8 moles C5 H10 O2. And then, since I have that, I want that on the bottom, and in my balanced equation, it is 2. The big coefficients in any balanced chemical equation are moles. So 2 C5H10 O2, and then I get 10 CO2, and it should say moles. You can make it say moles there. And so it's really easy. So it's 8 times 10, which is 80, divided by 2, which is 40. So if I start out with 40 moles of the reactant, or if I start out with 8 moles of the reactant, I get 40 moles of CO2, because you can see that it is a 10 to 2, which is 5 times ratio, okay? And I think we'll cap this video here, and then I'll show you another reaction, and we can do something different with it.